Good morning, IM3. Good afternoon, IM3. Today I'm going to go over our Check Your Understanding problem from yesterday. So for the first part of the problem, it says, excuse me, identify the degree of each function. So let's just do that. So for part A, part 1, okay. So our first degree we have here, f of x is degree, let's see, 3, because you see the highest exponent is 3. And we could say g of x, okay, is degree 4. The highest exponent is 4. So we got that first part of the problem completed. All right, so this is done. Boom, boom. Okay, estimate the coordinates of the local maximum or local minimum points on the graphs of the function. So here's where you have to go over the calculator. You put the equation in y equals. I'm going to go to a zoom and then 6. That gives me a standard 10 by 10 window. And I'm going to look at my graph. Now this is degree 3, so that means it'll have 2 turns. So when I look at my graph, I can see both turns. I see my local maximum and my local minimum. And let me try to find a place on my paper to type this in. So, so for f of x, we could say for f of x, right, the local maximum is, and we'll fill this in a second, and then the local minimum is, minimum is, okay? So if we hit our trace key right here, we hit trace, we'll trace along our curve, and we notice that, I'll go to do the maximum first. When we're tracing, we get kind of close to negative 2.4 and 9.2, okay? Maybe negative 2.5 and 9, so I'm going to type that in as my local maximum, negative 2.5, comma 9. And we see that right here, our x and y, we got that by hitting the trace button. So I'm still tracing along my curve, and my local minimum is going to be somewhere around, right around here, okay, negative, let's see, negative 0.15 and negative 2.2, so let's just fill that in. So negative 0.15, comma, negative 2.27. That's good enough for this problem for f of x. Now we need to go back to our y equals, and let's just change our equation. So I'm going to change my equation. Okay, 2x. All right, change that to a 4. Change this to a subtraction symbol. It's 8x to the third. I'm just changing to the equation I see here, plus, and then I'm just going to type over this, 16x squared plus 4. Okay, I'm going to hit zoom 6 again to go to my standard window, and then I think part of the graph is probably going to be missing for this. So while that's graphing, okay, yep, so I'm noticing I'm missing part of the graph, so let's move this down just a little bit. Okay, so so what I'm going to do is I'm going to go back to my window, and I want the y value to go higher. When I look at my graph, the y isn't high enough here, so I'm going to change my window. And I'm going to say my y max, let's say, instead of it being 10, let's move that to 20. So my y maximum is 20. All right, hit graph, and maybe I'll see what I'm looking for here. So I'm hitting graph, and I'm waiting for it. And while I'm waiting, I think I'm going to, yeah, so that gets just high enough right in there. So I can see my 2 local minimums and my local max. So let's get ready to type our answers in. Come on. Copy, paste. Alright, here we go. So for g of x, alright, our local maximum, we only have 1. We'll fill that in a second. Alright, and then our local minimums. Actually, here's a fun fact. That's actually plural for that is minima. So we put in 2 values. So let's go back to where we're going to be tracing our, excuse me, tracing our works. We hit trace. Our local minimum, it seems to be pretty close to 0.4. Right? That seems to be the lowest point. So 1 is going to be 0, comma 4. Wow, hold on. Oh, isn't that cute? That typed in the calculator. 0, comma 4. I wanted to type here. All right, let's still hit trace, and let's trace over to our other point. So we go right here. Okay, and that looks like about, let's see, 4 and 4.13. That's kind of the lowest y value we can get, right? So I'm going to say this is about x equals 4 and y equals 4. So let's put that as our other local minimum point, 4, comma 4. And then our local maximum point would be right in here, right? Somewhere up top there. So it looks like that's about close to 20, right? 19.99, right? And this is about close to 2, so let's estimate that this is 2, comma 20, all right? And that's our answer for that section. All right, the next part of the question, we have an equation and we have to find a model of this. All right, and we start that by identifying key points on our curve. Now we notice that this is going to be degree, it's got 3 turns, so let's type that in. So it has 3 turns, so it's going to be degree 4. So that means it's going to be a quartic function. That's going to be important in a second. We go to use this in our calculator. Our first step is identify some key points, so let's just type them in. So this first one I'm going to say is 0, 0. This one right up here, well, the y value is 10. It looks like maybe it's like, I don't know, 0.9 comma 10. That looks pretty good. This point down here, it looks like a y-intercept, so that's probably 3.03 comma 0. And then our high point up here, maybe it's just after 5, so maybe like 5.1, right? Like this point right here, right after 5, 5.1 comma 10. And then here we have the point 6 comma 0, 6 comma 0. All right, so we notice that we have degree 4. We have to have one more coordinate than we have points. So our steps to take to the calculators, we have to go to our stat. Okay, we have to go to edit, and we have to create a list of these values right in here. So I'm going to take a second and I'm going to create the list of these values. Okay, so I've taken the time to put all of our coordinates in. I think I can take it and drag it right here. Hopefully my computer will do what I want it to do so you guys can see this. So you can see that my list values, all right, if you look at them, let me just get everything on the same screen. 0 goes with 0, just like here. 0.9 and 10 go together. 3 and 0 are friends, they go together. 5.1 and 10 go together, and then 6 and 0 go together. Okay? So once we have that in, then really that's the main part of the problem. Now that takes the most amount of time to type that in. We have to go back to our stat key right here. We go over to where it says calculate, and we want to calculate the quartic regression because this is degree, has 3 turns, 1, 2, 3 turns. All right, and since it has 3 turns, it's 1 degree higher, so it's quartic, so we go down to 7. You can just hit 7 also. So we go down to 7 and hit enter. And then we go down to calculate, and that's going to tell us our equation. Calculate, enter. And then after we do that, this screen shows up, and this tells us our quartic regression. So boom, boom, boom. All right. Here's our quartic. This is what kind of shows up, and this tells us our equation. So our equation might look like this, right? Our equation would be y equal ax, so that's a negative, let's say 0.5x to the 4th power, and I'll change that in a second, plus 5.9, so I'm going to 6x to the 3rd power, because that's a 3rd power, plus, actually minus 22x to the 2nd power, plus, and I'm going to round that to 27. All right, now all these exponents, these are actually exponents, so let me just make them look like that. I can remember how to do it. Here we are, right here. Exponent, exponent, and then that's the exponent. Exponent, okay? So we can go ahead, and once we do that, we can actually check to make sure that in our calculator that makes sense. So I'm going to turn my plots on. That'll show me my plots, and I'm going to change this equation to the one I just typed in. So that's y equal, it's negative. I like to separate the negative and equal. So negative 0.5 x to the 4. All right, bump it down, plus 6 x to the 3rd, right, minus 22 x squared plus 27. Okay, that's what we have, and I'm going to go ahead and I'm going to hit graph, and hopefully the points that I have plotted here and the curve I have done, I've typed in, hopefully that curve goes through those points, and it doesn't. What's going on? Something happened. So, oh, this should be 27x. Look, that the D is the 27x. That should be x. So it's always good to check your work. That should be an x right there. So let's go back and change this. Type of x. All right, let's go ahead and graph, and hopefully our points that we've plotted, these are the same points that we identified right here. Hopefully that our graph now goes through those points. Let's hope. Yep, there we go. Oh man, we're missing something. So I played around with this a little bit. I changed this to 22, this negative 22.23 in the equation. I've changed this here. And my graph is still coming out kind of wrong. So this is why it's called a model. It's not an exact, because I think we would need to have more points and maybe a little bit more exact points in order to get a model that fits better. But this, for the sake of doing the problem, this is kind of what I'm expecting to see. I'm expecting to see that you identify the degree plus 1 number of points, so 5 points, and then you come up with an equation for it. So clearly, if you had numbers close to this, I would give you the full points for it. So that's how we do this type of problem.